Today we're going to be learning how to square binomials. So this is an important concept, one that's going to come up in a lot of your math classes and further on in your college career. So it's pretty important. The first thing that I want to talk to you about is squaring. So what is squaring? Because there's two parts to this concept, right? The squaring part and the binomials part. What I want to do is just give you the quick definition of what squaring is. It's really easy. So squaring is when we raise something to a little 2 like this. All that it means is we take what's underneath the 2 and we multiply it by itself. So 2 squared would be equal to 2 times 2 would be equal to 4. And if we had 6 times 6, that would be equal to 6 squared. And then I know that that's 36. So I'm going to write, in general, squaring is when you take something, let's say A, you raise it to a little 2, and all that means is you multiply it by itself. So the second part of squaring binomials, just quickly, is what is a binomial? This is about as easy as the definition of squaring. All that it means is something of this form, where you have a variable and then a number in front of that variable, and then some sort of sum or difference, and then just another number on the other side of the sum or difference. So some examples would be 3c plus 5. The variable doesn't have to be x, it could be any sort of letter or symbol. So 4b minus 9 would also be 1, and 5 smiley face plus 3 over 2 would also be a binomial. Okay, so now we know what squaring and binomial, what those things are. Now how about we put those two concepts together? That might seem like a little bit of a difficult concept, so what about squaring binomials? Binomials. Binomials. So your first instinct might just be to bring the little 2 down. So first of all, let's give a little bit. Hope the smartboard's okay. Let's look at 2c plus 4 squared. This is definitely not just bringing down the little 2. So you definitely don't want to do this. Don't do this. Right? Because what's the definition of squaring? You just take what's underneath the parentheses and you multiply it by itself. Sorry, what's underneath the little 2? What's in the parentheses is what's underneath the little 2. So that's the thing you multiply by itself. Okay. A lot of you guys immediately want to use the foiling method. And foiling is first, outside, inside, last, where you take the first and then you multiply those, and then you add to that the last 2c times 4, and then you keep doing that following the what's that, acronym? Yeah, it's an acronym. What I'm going to do is show you where that comes from, so you don't have to remember the acronym, you can just understand the math of what's going on. And to do that, I want to talk to you quickly, not even talk to you, just kind of jog your memory a little bit about distribution. So if I gave you something like this, you would distribute the 7, right? If I said 7 times c plus 5, you would tell me that that's 7c plus 7 times 5, and that's equal to 7c plus 35. So I'm going to put this in a little bubble. This is the distributive property. And how's that going to help us with squaring binomials? Well, it turns out that you can just treat the binomial above each little thing in the parentheses as its own 7, like in our example above. So let me rewrite this step. What I want to do is treat this whole binomial as its own 7 and distribute it across, and that's going to give us the foiling method that we all know and love. So 2c plus 4 times 2c, that's that first arrow, and then you add 2c plus 4 times 4, the second arrow. So all I'm doing is using the distributive property, but I'm applying it to binomials. And then from here we use the distributive property again. This one's a little easier to see because it's the one you know. So we get 2c times 2c plus 2c times 4, and I guess I'll draw the arrows here again. You get 2c times 4 plus 4 times 4. So a few of you might have just noticed, here's what we did. We got FOIL first, outside, inside, last. That's a weird L. Okay. So foiling is really just distributing twice. So hopefully now you'll never struggle to remember the foiling method because you understand where it's coming from. All of you guys know the distributive property. All we're doing is using it in binomials. So now I can clean this up a little bit. You get 4c squared here. Each of these is going to be an 8c, so 2 of those would be 16c. And then 4 times 4, interestingly enough, is, I could rewrite that as 4 squared, right? But it's also just 16. So that would be squaring this binomial. Let's go back up and try and solve the original binomial, just as an extra example. So you can see, back to the original example. When we're squaring binomials, we're really just using the distributive property twice. And we're also using the rule of squaring. So pretty sure that my example above was this. First thing I want you to do, use your rule of what squaring is. Whatever's underneath the 2, take that and multiply it by itself. Now, distribute this. I'm going to put this in green actually. So we want to treat a plus 3 as its own quantity and distribute it into the next parentheses. So we get a plus 3 times a plus 3 times 3. And then distribute this back in on both terms. So you get a squared here plus 3a. Oh no, got to keep everything consistent. I don't want to write that in green. That'd just be crazy. Crazy. All right. These first 2 terms are from there, and then I'm moving on to the second one now. So you get 3 squared, which would be 9, and you get 6a in the middle here, 9. So there we go. That's 2 examples of squaring binomials and an explanation of where the FOIL method comes from. Hopefully you guys can use the FOIL method, but your mathematical understanding will be much stronger if you understand where FOIL is coming from. And it will also help you out later on in your maths if you really grasp where this distributive property is being used and how it works. So that's how to square binomials. I hope this helped, guys. Have a good day.